Students, welcome. Today we are going to start Unit 8 of class 11th in chemistry, and this unit is about redox reactions. Redox reaction इस वर्ड को अगर हम देखें, redox वर्ड को, ये दो वर्ड से मिलकर बना है. एक वर्ड है रिडक्शन और दूसरा है ऑक्सीडेशन. तो रिडॉक्स रिएक्शन हम उन रिएक्शंस को कहते हैं जिनमें रिडक्शन और ऑक्सीडेशन एक साथ होते हैं simultaneously. So what will be the definition of this redox reactions? The chemical reactions in which both oxidation and reduction take place together. They are called as redox reactions. Now we have several concepts about what is oxidation and what is reduction. We will begin with the classical concept of oxidation and reduction. Now, according to classical concept, what is oxidation? Oxidation is a process that involves addition of oxygen or any electronegative element or addition removal of hydrogen or any electropositive element. So the process of oxidation involves four things: addition of oxygen or addition of any electronegative element. Similarly, it involves a removal of hydrogen or removal of any electropositive element. Now, on the basis of this definition, we will take some examples which come under the process of oxidation. Carbon combines with oxygen and forms carbon dioxide. Now see, in this process the carbon is undergoing addition of oxygen. So we can say that carbon undergoes oxidation. FeCl2, that is ferrous chloride, combines with chlorine and we get ferric chloride. Now in this case you can see that ferrous chloride undergoes addition of chlorine. Now since chlorine is an electronegative element, so we can say that ferrous chloride undergoes oxidation. Now another case is hydrogen sulfide plus bromine. In this reaction we get sulfur as the product along with hydrogen bromide. Now again in this case we can see that a hydrogen sulfide undergoes the removal of hydrogen, because hydrogen sulfide, after the removal of hydrogen, is forming sulfur. So a removal of hydrogen is taking place from hydrogen sulfide, so we can say that hydrogen sulfide undergoes oxidation. Now in another reaction, potassium iodide reacts with hydrogen peroxide to form iodine and potassium hydroxide. Now we can see that in this reaction, potassium iodide gives iodine as the product. So what is happening? From potassium iodide, potassium is being lost or potassium is being removed. So we know that potassium is an electropositive element. So removal of electropositive element is taking place from potassium iodide. Therefore, we can say that potassium iodide undergoes oxidation. Now reduction. Reduction is the process that involves the addition of hydrogen or any electropositive element or the removal of oxygen or any electronegative element. So again, in case of reduction, we can see that there are four processes which are included in reduction: addition of hydrogen or addition of any electropositive element and removal of oxygen or any electronegative element. Now we will see some examples for the reduction processes. Nitrogen plus hydrogen gives ammonia. Here we can see that nitrogen undergoes addition of hydrogen. So we can say that nitrogen undergoes reduction. Mercuric chloride, HgCl2 is mercuric chloride. It reacts with stannous chloride and gives Hg2Cl2, that is mercurous chloride, and SnCl4, that is stannic chloride. Now see carefully what is happening in case of mercuric chloride. Mercuric chloride is changing into mercurous chloride. It means in this molecule an atom of mercury is being added. Now mercury is a metal and is electropositive in nature, so we can say that mercuric chloride undergoes addition of a mercury atom or electropositive element. Therefore we can say that mercuric chloride undergoes a reduction. Now in another example, zinc oxide reacts with carbon to form zinc and carbon monoxide. Now see, in this case, zinc oxide is losing an atom of oxygen. So removal of oxygen is taking place. removal of oxygen is called as reduction. Ferric chloride, when treated with hydrogen, gives ferrous chloride and HCl. Now ferric chloride is changing into ferrous chloride. It means ferric chloride is losing an atom of chlorine, or we can say it is losing an electronegative element. So it becomes reduction. So in this way, you have seen both the cases of oxidation and reduction along with their examples. Now coming back to the first case, that is ऑक्सीडेशन. जैसे हमने ये एग्जांपल्स डिस्कस की हैं, इन केस ऑफ ऑक्सीडेशन हमने कहा था कार्बन अंडरगोज ऑक्सीडेशन, फेरस क्लोराइड, हाइड्रोजन सल्फाइड, पोटेशियम आयोडाइड, these are the species which are undergoing oxidation in these examples. Now which species are responsible for their oxidation? These are the species: oxygen, chlorine, bromine, hydrogen peroxide. These are the species which are bringing about the oxidation of carbon, ferrous chloride, etc. Now these species which bring about the oxidation, which are not themselves undergoing oxidation, but they are bringing about the oxidation of the species like carbon, ferrous chloride, hydrogen sulfide. These species are called as oxidizing agents. Similarly, coming on to the cases of reduction, हमने जो एग्जांपल्स डिस्कस की हैं, हमने देखा नाइट्रोजन, mercuric chloride, zinc oxide, ferric chloride. These are the species which are undergoing reduction. Now which species are responsible for that? Hydrogen, stannous chloride, carbon, hydrogen. These are the species which bring about the reduction in these cases. And what are these species known as? These are known as reducing agents. So from the above discussion, we can define what is oxidizing agent and what is a reducing agent. So the species which bring about oxidation are known as oxidizing agents, and the species which bring about reduction are known as reducing agents. Now in the definition of redox reaction, we said that these are the processes in which both oxidation and reduction take place together. That means at the same time or simultaneously. To explain that, take the case of reaction between zinc oxide and carbon. When zinc oxide is heated with carbon, we get zinc and carbon monoxide. Now according to the definition of oxidation and reduction, we can see that zinc oxide undergoes loss of oxygen. and loss of oxygen is called a reduction. So zinc oxide is undergoing reduction. And what about carbon? Carbon is undergoing gain of oxygen or addition of oxygen, and addition of oxygen is called oxidation. So we can say that on one hand zinc oxide undergoes reduction and on the other hand carbon undergoes oxidation. So both the processes are taking place simultaneously. That is, oxidation and reduction is taking place together. So this reaction is a redox reaction. Now coming on to the concept of oxidizing and reducing agent, हमने कहा था कि जिंक ऑक्साइड की रिडक्शन हो रही है and which species is responsible for bringing about the reduction? This is the carbon. So carbon is in this case acting as the reducing agent because carbon brings about the reduction of zinc oxide. Now which species is bringing about the oxidation of carbon? We can see that zinc oxide is bringing about the oxidation of carbon. That is, zinc oxide is acting as the oxidizing agent. Now, in case of zinc oxide, we can see that zinc oxide is undergoing reduction and it is behaving as oxidizing agent. Carbon is undergoing oxidation and it is behaving as reducing agent. So from this we can generalize that the substance that undergoes reduction acts as the oxidizing agent and the substance that undergoes oxidation is known as reducing agent. So from this discussion we can conclude that a substance that undergoes a reduction acts as oxidizing agent and a substance that undergoes oxidation acts as the reducing agent. Now the second concept of oxidation and reduction is electronic concept. In this concept, oxidation and reduction are defined in terms of transference of electrons between the substances. Now, according to electronic concept, oxidation is the process in which an atom or ion loses one or more electrons. It means the loss of electrons is called as oxidation. For example, sodium forms sodium cation Na positive by losing an electron. So this is the process of oxidation. Ferrocene Fe2 positive forms ferric ion by the loss of one electron. So we can say that ferrous ion undergoes oxidation to form ferric ions. In these two cases, we can see that the positive valency is increasing. Similarly, if we have a negative ion like MnO4 2 negative, this is called manganate ion. It forms MnO4 negative, that is permanganate ion, by the loss of one electron. So loss of one electron means oxidation. Sulfide ions S2 negative, it can form sulfur by the loss of two electrons. So loss of electrons again, so we can call it as oxidation. In these two cases now, we can see that there was negative valency and this negative valency decreases. So as a result of oxidation, we can see that the positive valency increases while the negative valency of a substance decreases. Now the process of oxidation is also known as de-electronation. What is the meaning of de-electronation? It means the loss of electrons. Now according to this concept, we will define the process of reduction. Now what is reduction? It is a process in which an atom or ion gains one or more electrons. For example, chlorine gains an electron and forms Cl negative ion, that is chloride ion. Ferricyanide ion. Ferricyanide ion gains an electron and forms a ferrocyanide ion. So these are the cases in which a species is gaining electrons. So these are examples of reduction. In these two cases, what is happening to the valency? We can see that the negative valency is undergoing an increase. So with reduction or with the gain of electrons, what happens? The negative valency increases. Now Sn4 positive, that is stannic ion, gains two electrons and forms Sn2 positive, that is stannous ion. So this is a case of reduction. Similarly, ferric ion gains an electron and forms ferrocide. So in these two cases again there is gain of electron, so these represent reduction. And if we see the valency of the species, the valency of tin and iron was positive and it is undergoing a decrease. So in case of reduction, the positive valency decreases, and on the other hand negative valency increases. And reduction is also known as electronation. Electronation means the gain of electrons. Now, in the above examples, we have seen that some species can gain electrons and some species can lose electrons. Now, this process always takes place simultaneously. That means the loss of electron is always accompanied by the gain of electrons. Means the two processes take place simultaneously. So the reaction is always redox. So when we talk about oxidation, oxidation is only one half of the reaction and the reduction is the other half of the reaction. Therefore, whenever we talk about oxidation, we say that this is the oxidation half reaction. And when we talk about reduction, it is another half of the reaction. And when these two half reactions combine or when they are added, we get a complete reaction, that is the redox reaction. So oxidation is not a complete reaction, it is only one part of the reaction. Now see a complete redox reaction. When sodium metal is heated with chlorine gas, what is formed? We get NaCl as the product, sodium chloride as the product. And in sodium chloride, we know that Na positive and Cl negative exist. So here we can see that sodium atoms are changing into sodium ions, and it takes place by the loss of electrons. And loss of electron is called as oxidation. And if we look onto the chlorine, chlorine changes from zero oxidation state to -1 oxidation state, and it is by the gain of electrons. And gain of electrons is called reduction. So when sodium and chlorine react to form NaCl, sodium undergoes oxidation and chlorine undergoes reduction. Therefore, this is a redox reaction. Now, on the basis of this concept, that is electronic concept, the redox reaction is classified into two types. Direct redox reaction and indirect redox reactions. Now, what is the difference between direct and indirect redox reactions? In case of direct redox reaction, the oxidation and reduction take place in the same container or at the same place, which means that the oxidizing agent and the reducing agent the oxidizing agent and the reducing agent are in contact with each other. That means there is a direct transfer of electrons between two species. And when we talk about the indirect redox reaction, these are the redox reactions in which the oxidation and a reduction take place in separate containers. That means at different places. And oxidizing and reducing agent are they are not in a direct contact. They are not in a direct contact with each other. Means they are connected to each other through some other medium like an electric wire. See, for example, if we take a solution of copper sulfate and dip a zinc rod in this solution. Now we know that in zinc rod there are atoms of zinc, and in copper sulfate solution there are copper ions, that is Cu2 positive aqueous are present in copper sulfate. और जब ऐसा होता है, जब जिंक रॉड को हम कॉपर सल्फेट सॉल्यूशन में डिप करते हैं, व्हाट हैपेंस, द जिंक एटम्स and the copper ions, they undergo exchange of electrons. The zinc atoms lose electrons and form zinc ions, and copper ions gain electrons to form copper atoms. Here we can see that zinc undergoes oxidation by the loss of electrons, and copper ions undergo reduction by the gain of electrons. And the zinc atoms and the copper ions, they are in a direct contact with each other. So this is an example of a direct redox reaction. Now the same reaction can be carried indirectly as well, like in case of electrochemical cells. Galvanic cell is such an example. In galvanic cell, we have two separate containers. In one container we have zinc sulfate solution, and in the second container we have copper sulfate solution. Zinc rod is dipped in the zinc sulfate solution, and a copper rod is dipped in copper sulfate solution, and they are connected with each other and a galvanometer is connected in between, and they are connected through a wire which is made up of copper. And there is also another substance which is called salt bridge. And the salt bridge completes the circuit in this case. अब हम यहाँ पर क्या देखते हैं कि ये जो गैल्वेनोमीटर फिट किया गया है, इस गैल्वेनोमीटर में एक डिफ्लेक्शन मिलती है, और वो डिफ्लेक्शन इंडिकेट करती है कि इलेक्ट्रॉन्स इसमें फ्लो कर रहे हैं, कॉपर वायर के थ्रू इलेक्ट्रॉन्स फ्लो कर रहे हैं जिंक रॉड से कॉपर रॉड की तरफ। और ऐसा क्यों हो रहा है? ऐसा इसलिए हो रहा है क्योंकि इस कंटेनर में, ये जो जिंक सल्फेट का कंटेनर है, इसमें जिंक आयंस, जिंक एटम्स इलेक्ट्रॉन्स लूज करके जिंक आयंस बना रहे हैं। Zinc atoms are losing 2 electrons to form zinc ions, and those electrons are flowing through the copper wire towards the copper electrode to the copper rod, और copper rod जिसके contact में copper ions है in the solution of copper sulfate, those copper ions are gaining the electrons to form copper atoms. In this case, the same reaction is taking place as we discussed in the above example. In case of direct redox reaction, जो example हम discuss कर रहे थे, same reaction is taking place, but the two half reactions, these are the two half reactions, they are taking place in separate containers. और चूंकि electrons flow कर रहे हैं through a wire, therefore electric current is produced. And in this way an electrochemical cell is formed. So electrochemical cell works on the principle of indirect redox reaction.